So what if the biggest rule in the AI race, the one that says the biggest budget always wins, is suddenly completely wrong? Today, we're going to dive into a massive shift happening in artificial intelligence. It's a story about how one company got to the top not by spending more money, but by being way, way smarter, creating a model that's up for 100 times cheaper than its rivals.
All right, let's just jump right into the heart of it. On the left, you've got the cost to train a massive Western model like GPT-4. We're talking anywhere from $100 million to $1 billion. Now look at the right, DeepSeek. Their training budget, about $5.5 million. I mean, we're not talking about a small discount here. This is a fundamental, industry-shattering collapse in cost.
Which, of course, brings us to the big question. How on earth is that even possible? How can a model get on the same level as the world's best for literally pennies on the dollar? Well, that's the mystery we're about to unravel.
So, what's the secret sauce? The biggest piece of this puzzle, the core technique that unlocks all this insane efficiency, is something called model distillation. And it's a completely different way of thinking about how to make an AI smart.
Okay, think of it like this. You've already got this huge, expensive, PhD-level teacher model that's been trained. Now, instead of making a new student model read the entire internet from scratch, which costs a fortune, you just have it learn directly from the teacher. But here's the key. The goal isn't for the student to just copy the teacher's answers. It's to learn how the teacher thinks.
And that brings us to this really cool concept they call dark knowledge. It sounds kind of mysterious, right? But it's a powerful idea. It means the student learns to pick up on all the nuances, the uncertainties, and the subtle connections that the teacher model has figured out about the world. It's not about just learning facts. It's about absorbing the teacher's intuition.
And this example just lays it out perfectly. The old school way, traditional learning, you show a model a picture and you tell it, with 100% certainty, that is a dog. That's a hard target. But with distillation, the teacher provides a soft target. It says, hey, look, I'm about 90% sure this is a dog, but, there's maybe an 8% chance it's a wolf and a practically 0% chance it's a sandwich. That 8%, that's the dark knowledge. It gives the student this incredibly rich piece of information. Dogs are a lot like wolves, but they are nothing like sandwiches.
Okay, I know what you're thinking. You see a formula like this and your eyes just glaze over. But don't worry, all this really is a balancing act. The whole training process becomes this tug-of-war between two different goals. One, get the right answer, that's the L hard part, and two, think like the teacher, that's the L soft. It's just a way to mathematically enforce this much richer, more nuanced way of learning.
So let's just quickly look at how these pieces fit. You've got the soft targets, which are just the teacher's best guesses. Then you have this dial called temperature that you can turn up to squeeze out even more of that hidden dark knowledge. And finally, you use a math tool, in this case it's called KL divergence, to basically measure how different the student's logic is from the teacher's. And you're always trying to make that gap smaller and smaller. It's a really elegant system. All right, let's move on. Because as clever as distillation is, it's only one part of the story. DeepSeek didn't just stumble on one little trick. They designed an entire architecture of efficiency right from the very beginning. So how else do they squeeze out so much efficiency? It really comes down to how these models think. A traditional dense model is like using your entire brain, every single neuron, to process every single word you read. I mean, it works, but it's incredibly wasteful. DeepSeek uses what's called a mixture of experts, or MOE model. This is way more like having specialized parts of your brain. When it sees a math problem, the math expert lights up. When it sees code, the coding expert takes over. It's just so much more efficient. And the results of that MOE architecture is, well, it's just staggering. The full model is a massive 1.6 trillion parameters, which gives it this incredible depth of knowledge. But for any single task, it only activates 49 billion of them. That means it has the knowledge of a super heavyweight champion, but it uses the energy of a flyweight. We're talking a 95% reduction in compute. It's just unheard of.
So when you put all the pieces together, what you get is this incredible blueprint for efficiency. We've talked about mixture of experts slashing the compute costs and distillation letting them bypass a ton of expensive R&D, but they also layered on other things, like a smarter optimizer so the model learns faster, and a new kind of memory system. Literally every single piece of this thing is designed for maximum efficiency.
But, and this is a big but, this story isn't just about clever software. It's also about hardware. And that's why some are calling this whole approach an architecture of defiance. It's a strategic and very deliberate move to build world-class AI completely independent of Western chip supply chains.
And this hardware comparison tells you everything you need to know. Because of export controls, the best NVIDIA chip you can legally get in China is the H20. But DeepSeek's new models were designed to run on Huawei's own domestic Ascend chips. And if you just look at the performance, the Ascend chip is nearly 3 times more powerful. This shows a clear path for them to keep pushing the envelope on AI, no matter what happens with geopolitical restrictions.
So, we have an ultra-efficient model, built on top of powerful domestic hardware. Why does this send a shockwave to the global AI world? Because we are now looking at the very real consequences of top-tier intelligence becoming a commodity.
And the implication here is, it's profound. The old moat is gone. The idea that only a handful of companies with billion-dollar budgets could build frontier AI, that idea has just been shattered. That massive barrier to entry has been completely obliterated.
Now, this new reality creates a huge security dilemma. According to the source material, U.S. officials have called this process of large-scale distillation an industrial-scale campaign. And the big concern is that now anyone can take a powerful, open-weight model, distill all of its amazing capabilities, and then just strip away all the safety features and guardrails that were built in. And if you want to see that shockwave hitting the real world, just look at the financial markets. After a previous model release from this same company, NVIDIA's market cap dropped by $500 billion in one day. People started calling it a Sputnik moment for the hardware market, because it showed that if smart algorithms can replace raw computing power, then the entire economic foundation of the AI industry is up for grabs.
Okay, so let's bring this all down from the 30,000-foot view of geopolitics. What does this new world of ultra-cheap, ultra-powerful AI actually mean for businesses right now, today?
Well, this is what the new economics of AI looks like in practice. Analyzing a whole code base, that drops from $35 to about $5. Running a customer service agent 24/7, that goes from $12 a month to just 30 cents. This doesn't just make things cheaper. It means whole new categories of products that were never economically possible before suddenly are.
And this is kicking off a massive trend, the return of self-hosting. I mean, think about it. Why would you send your most sensitive data to a third-party API when you can run a model this good on your own servers? You get total data sovereignty, it makes compliance way easier, and it completely changes the economics. AI stops being a monthly utility bill and becomes a one-time asset. Once you own the hardware, every new token you generate is practically free. So this is where we are. Through this incredible mix of clever algorithms and super efficient architecture, the price of frontier AI has collapsed. It's becoming a commodity, something as accessible as electricity. Which leaves all of us with one huge and very urgent question to think about. What happens next?